from various branches. Anyone from telecom? All right, I'll take that as a no because I don't see any hands raising up. Okay, so let's try and keep this session interactive. If you have any questions during the sessions, please feel free to put those or raise your hand or drop those queries on the chat window. Anyway, we do have a Q&A in the last, so we can take up any questions that you have. Okay, let's get started now. I'll start with a brief introduction about myself. I'm Vikaas Shivalingappa, an IT architect by profession, working for MNC, and my clientele is a telecom clientele, and we build APIs to secure data and to integrate internal and external systems. In these recent times, we have seen how telecom industry has impacted our lives, right? We have mobile and the internet data, which a few years back was more of a luxury or a fancy, has now turned into a basic necessity for us, all thanks to COVID. And in this pandemic, we are seeing many use cases for the internet usage. I mean, it's become a basic necessity, from payments to whatnot, educating children and work from home, and even your medical appointments and entertainment, streaming data. All of these has become part and parcel of our lives, right? And in these recent times where everyone is glued to the internet and mobile data, I'm sure all of you would have felt that there is a glitch in the network, or your coverage could have been better, or there is a poor quality in video and all of that. And I'm sure pretty much everyone would have wondered that, we would have got a better connectivity or better quality of network. So answer to that is the new generation of this wireless technology. That's the 5G technology. Okay, I think let me start sharing my screen. Give me a minute. Let me know if you all can see my screen.
Yep.
Okay. Meanwhile, let me get off the. Cool. Can you all see my screen now?
Yeah, it's visible.
Great. So yeah, in today's session, we'll have this agenda. We'll have a brief introduction to the 5G. We'll see how 5G has evolved from 1G to 5G, key features of 5G and use cases, and how it works, and the challenges that we face. And then we can have a round of question and answers. And yeah, that's the agenda for today's evening. Okay, let's quickly talk about the 5G network, right? So with all these background that we got about the necessity for the a better internet connectivity, well, this whole thing started much in advance, predates to COVID era. But now, after the COVID times, I think it has become more relevant, and there is increased focus in this new technology, right? So this technology, as it promises, it provides a faster, reliable, and a diversified communication, so that we can have a better um, experience of mobile and cellular technology, right? So this is the new global wireless standard of network, and the 5G, the full form is fifth generation of network, right? So this aims to provide faster speeds, lesser latency. When I talk lesser latency, the response time, when you send a request and the moment you get the response, that time is called as a latency. So we are looking at a very less response times from whatever the requests that we make. And this technology aims to connect everything, everyone, and everywhere. So that's the motto that they have. And well, who invented this technology? Well, there is no one person. This is a collaborative efforts of all the telecom industry giants and the forum, the third generation partnership project. So they have pivoted this whole efforts, and they're driving all the design aspects of the 5G. Right, let me move to the next slide. This talks more about uh, your evolution of 5G. So initially, this all started in 1980s, where we were just having the analog phones. I'm not sure um, you would have even experienced the old date telephone models that you see in the movies and all. So that you can consider as the first generation of mobile or cellular communication, wherein you were just talking over analog voice data, where this can be the early mobile phone times. One sec, sorry. And after 10 years of period, we in the 1990s we saw the 2G, wherein along with the digital data, we were also getting these features of SMSs and texts and MMS, and these new things were introduced. Um, at the moment, if you see, it all seems very minor changes, but moving away from analog to a digital voice, the technology involved behind that was tremendous, right? And what we have also seen is that if you notice, there is a changing trend every 10 years. So in the next in the 2000 era, we started seeing mobile broadband, wherein we are talking about high speed data and internet access on your mobile, and making video calls, etc., right? And in 2010s we started seeing better quality of audio calls, or high HD television, and HD streaming apps from your mobile. I mean, you could view all your movies or the serials, or I mean, it was more of entertainment specific that we started seeing in your 2010 era. Now in 2020s, we are talking about another advanced level, wherein we are saying that we are empowering the devices, not to respond to what we ask, but we are talking about devices having its own trigger point, so that they can start sending you notifications. I mean, you don't have to go ask them for the data. As soon as there is a trigger event, then those devices going to talk to you by themselves. That's the iota era of this data. So for all of these new features that we are talking, there has to be a reliable system for so that the applications can connect with each other, talk to each other, right? So that's the technical term that is paving way for this 5G evolution. So in this, we are just not talking about enhanced mobile experience, but we are talking about something like virtual reality, autonomous driving, etc. Let me move on to the next slide. Right. So the key features in this 5G technology that we are talking is about the speed. So the minimum speed it promises is 10 gigabytes per second. I know we are nowhere in the real world. The current data would be probably your 2 Gbps, etc. But in the 5G environment, we are talking a minimum speed of 10 Gbps, right? And less latency. Latency, as I already mentioned, it's the response time when you request for a certain thing and you get a response. So at the moment, think we are in terms of seconds and etc. But with this 5G technology, it will be more like a millisecond um, based response times. Sorry. And of course the connectivity also increases with this technology, increasing the capacity as well. So if we concentrate on the 5G key features, the three main things are uh, enhanced or extreme mobile broadband coverage with critical machine to machine communications, and you have massive machine to machine communications. So we're talking about lot of sensors talking to each other, sending data to each other, and interacting with each other. So that's something that we are looking towards the 5G in the 5G arena. And are we talking about something which is already there, or where are we with the 5G technology per se? uh, it's just has kicked off. I wouldn't say that it's fully mature enough, or there are um, uh, there are a lot of use cases or anything, but it is still evolving, and we are still there are a lot of potentials, and the scientists and the providers and the consumers are working towards making a different level of mobile experience for all of us. Right. Let us move on to the next one. I think we have yeah, so that's the use case that I was talking to you about. It's an enhanced mobile broadband, wherein we're talking about virtual reality. So I think gamers, if there are anyone here, I know you know what I'm talking about. You have these new goggles that you wear, and you start playing games. You feel as though you are in the game, part of that game, and it gives a different thrill altogether. So that's something about virtual reality. But what we are talking about now is augmented reality, wherein you can touch, feel, and even have you can smell. So that level of simulation is what this new technology has a potential to bring out to or offer to us as consumers. The next other use case is about mission critical communications. So this can be in the medical fields, or very dangerous industries where currently certain tasks are done manually. For example, if you have to go find a temperature in a furnace and all of that, so you will have sensors. And at this point, I think there will at least be some minimal manual intervention needed to even turn those switches on or off. But in IoT enabled environment, we are looking towards automating all of those, and handling all of those with drones or much more advanced technology, so that uh, we can automate most of the things, and um, have a safer or a environmental friendly environment for all the end users. So that's the aim in terms of mission critical communications and massive IoT. So as I said, we are talking about lot of sensors sending uh, data triggers to each of them. And for example, I can think of a use case wherein I'm a I have a passion in gardening and home composting, right? So whenever I travel, I always feel very uncomfortable going away from hometown, because there's no one to take care of the plants and all of that. So we are talking about sensors which can either read to the weather forecast, and based on the weather forecast, I can have it plugged to automated irrigation system or a drop water system, which can turn on based on the weather. If it's too hot, it can run the timer for a longer time, or if it is too hot, if it's raining, then I don't need watering my plants. So based on the weather triggers, I can automate the whole solution, so that I can have my plants watered through a drip irrigation kit. So all of this you can control again with your mobile and your internet access. So all of these data will be interconnected, and it will be keep sending notifications to each other to see what's the trigger points and how it should behave. So all of these are part of the IoT Internet of Things use cases, wherein 5G forms a basis for these use cases to work on, right? Okay. So now, how does this 5G technology work? I mean, how is it so different from the 4G technology? So in order to understand that, we have to understand these five main major technology terms that will stand apart from the other networks that we have had so far. So the first one is millimeter waves, and the next one is small cell, massive MIMO, beamforming, and full duplex communication. Right. So we'll go through each of these um, one by one, and we'll try to understand. Um, until now, is anyone having any questions or queries on 5G or any of the terms or items that we discussed so far?
No, it's all clear till now.
Okay, cool. So let me get started with millimeter waves. Okay, so millimeter waves, right? So in the regular environment that we are having in the 4G systems, the systems interact with each other with certain frequencies, which is between 3 kilohertz to 6 gigahertz. So this is the range of frequency where all our appliances, home appliances, mobile, and any communication related activities that happen. But as in when the internet is picking up, we are seeing that this range is getting crowded, and there is a need, or there is a need to space them even, so that they can start sorry, just give me a minute. Yeah. So what we were saying, where were we? These home appliances are all getting crowded in these frequency ranges, and in turn, which it is slowing the services, and you are experiencing dropped connections, like I mentioned before. So if every one of us in the same house, we are trying to connect to the mobile, because that's what happens usually at home. So when I start my work in the morning, I also have my son who is trying to start his classes, and then again my wife starts working. So all of us are hogging to the internet, and the devices start seeing drop in the connections, right? So the main thing is that the frequency of these communication is very narrow, and it is getting crowded, which in turn is increasing the droppages or slower services. So in order to overcome this, 5G technology looks at using the additional wavelength at higher frequency. Those are called the millimeter frequency range. This is between 30 hertz to 30 kilohertz to 300 gigahertz. So this range will, once it gets expanded, so that's when we get a lot of frequency modulation to space our appliances between, and it paves way for a broader area of connections. But the problem with these micro or the millimeter waves is that when they start propagating outside, any obstacles, be it a building or a tree or a cloud, because of these high frequency waves, they get absorbed and they start getting distorted. So in order to counter that, there is another technology that is bundled, so that millimeter waves can be effectively used. So that's this small cell technology. One sec. Right. So in the current 4G environment or any predecessors, we have one cell base which transmits signals continuously to different applications, right? And these communication relay depend upon a single large high power cell towers which broadcast signals at long distances. But the higher frequency waves, if we follow the same approach, then they will get distorted. Like I previously mentioned, even a building or a small obstacle can distort those signals, which in turn will reduce the clarity of the communication. So in order to avoid this, there is a new concept called small cells, wherein if you see here, there are small towers that are placed everywhere, so that the signal that gets transmitted from a high power cell tower is captured by those small cells, and then they propagate it across, so that even though the main signal is getting distorted, the cells that are the signals that are coming out from the small cells are triangulated in such a way that you get a better reception. However, this still have these two technologies alone won't solve the problem. We will have to also look at different options. Now that we are talking about small cells sending out sending out data in different fashions, there is also a need to receive those data, right? So if you see here, that's where the massive MIMO comes into picture. When I say MIMO, it is multiple input and multiple output. In today's 4G technology, for a cellular tower, there are a few ports that receive these data and send the data. So a port is a place where I mean, if I have to simply put it, that's where you send the data and you receive the data. So it's like a entry point and the exit point, right? So these cells have very less number of ports. In fact, it is in the number, I mean, it's just a dozen for a particular cell. With this amount of data that we are talking about, and a dozen number of ports will definitely not help. So what we are trying to do is there's a increased number of inputs and outputs, so that increases the capacity of the network also. So if you see the picture on my right hand side, we have cell towers which is having multiple number of ports. We are talking in terms of hundreds of numbers, right? However, the problem again appears that if you start sending all these data in all the directions, then again it will get distorted, which will again not help us in having a better clarity. So again, there is another technology that comes into picture which will try to reduce these distortions. So that is the beamforming. So this one to simply put it, you can take it up as a traffic signal, wherein you're sending instead of sending a signal in all the directions, it will send the data for a particular user in a particular direction. And there is a tower signal which acts like a traffic signal, which will modulate where the uh, um, beam of this signal can transmit to, right? So in this way, instead of sending the signal in all the direction, we are trying to send the data in a particular form, in the particular endpoint, so that the entire data is received by one receiver. So if you see here, there's a signal, traffic signal kind of a tower, which is sending data only for a particular mobile, right? I know the data, the picture that I've shown here is a very simple form of representation, but behind this, there's a lot of triangulation of the signals that goes into that happens in the background, so that a particular user gets a clarified signal from the tower. Uh, in order to do that, there will be several signals that have been that will be transmitted, and they'll be received back, and they will and it will forms a path so that it can reach the destination in a more effective way. So that's why 5G as a technology itself makes it complex, because all of these components will have to come in hand, so that you see a better um, um, clarity or user experience. So will all of this data coming into one form helps? Well, not really. Okay. So again, we are talking in terms of frequency. I mean, we're talking about data transmitting in one frequency from one destination to the other destination, right? That alone won't solve the problem, because here we are talking about milliseconds of response time, right? So I'm not sure if how many of you still remember your physics classes, wherein we had these half duplex mode of communication and full duplex mode of communications. So as a human, what we usually do is, when someone is talking, we listen, and when someone has finished their talking, that's when we talk, right? So that's how we pursue the data, and we understand it and then respond to it accordingly. Think about a scenario wherein a sender or a person who's talking uh, continues to talk, while the other person can also talk in the same time, and but still understand what this other person is talking about. I know it's a bit of a complex scenario, but yeah. So in that ways, what happens is, since there is a two-way mode of communication, it will reduce the time that is taken uh, to understand what the other person is telling, right? On a similar line, you can take an analogy of a train here. So if you see that it has a track with the 1 gigahertz kind of a frequency that denotes the frequency, and if a train has to move from one place to another, say from Bangalore to Mysore, it has to go in one track, right? And there's another train that is coming from Bangalore to Mysore, then you can't use the same track, because there will be a collision, and you'll have an accident. In a similar way, when the frequency of the waves travel in a certain frequency, then they have to be, if they are talking in the same frequency, then the sender and the receiver will have to wait until one person has stopped, so that it can transmit the same signal in the opposite direction as a response. But think about a technology wherein you have a switch in these tracks, wherein you're talking about the same frequency, wherein there is a mechanism to avoid that collision, and to traverse in such a way that both the sender and the receiver can send and receive data simultaneously, and still understand what the data is being transmitted. So that is something which brings in the reduced latency numbers in terms of milliseconds. So these five components are the basic things that is needed for the 5G technology to work. Of course, I know I've put it in very simple terms, but there is a lot of calculations and algorithms and whatnot involved to make this look so simple, right? Anyone has any questions?
I think no one has any questions.
I hope I'm not too fast. I hope everyone's able to understand what I'm talking about.
Yep.
Cool. Okay, so these are the key five components that is involved in the 5G technology. There is also network slicing and all of the other complex terms. I thought we'll just keep very simple for today's session, and probably we can look at deeper dive in the coming sessions, right? Okay, now coming to the challenges part. I know in India we haven't even started the 5G rollouts, whereas in the world across the globe there are some countries where this 5G has been rolled out um, at a smaller scale. Let's explore what are the reasons why this becomes so complex, right? The first one is the spectrum. The current spectrum that we are talking about, that is the 30 kilohertz to the 300 gigahertz range. That spectrum range is quite expensive, to usage, thanks to the 2G scam that happened and rocked our country a few years back. All the investors are not so keen on investing on the latest technology, and unless we have a good investment, we cannot bring up the infrastructure needed for the 5G to kick off. So it's just not the devices which are 5G enabled that need to be and that will enable us with this technology. We will have to start the infrastructure from the scratch, because the towers that we are talking about, we won't be able to use any of those. We will have to have those small cell towers to ensure that the signal transmits from one range to the other. And the MIMO part that I already mentioned, again, that's another infrastructure hurdle that we will have to take care and ensure that the connectivity is reliable. So people will still have to dig up earth and place the wires to ensure that all the connections are quite up to mark, to ensure that we talk about reliable connectivity. And most of all, I think we lack regulator body in terms of telecom industry, which can drive and ensure that the future generation of mobile needs are met, right? So I think that is the driving force, which once put in place will probably smoothen our 5G journey. And above all, I think the security and privacy also aspects also will have to be enforced, because our phone numbers are available everywhere, and it's now linked to Aadhaar and whatnot. And with the increasing technology trends and um, um, advancement, there is always a chance of higher risk. So we'll have to ensure that all of these things are in place, so that 5G rollouts in India can take on successfully. Well, I also wanted to include the advantages and the disadvantages of 5G, but at this point of time, the technology itself has not evolved, and there is a lot of potential about how this technology can be used to better everyone's life. At this point, I think we are too, that would be too judgmental to get into, how it is going to impact environment and all of that, because I've seen some reports. It says that a bird was exposed to the 5G signal, and it got that, it got this, and all of that. But we have to take that with a pinch of salt. We cannot completely ignore it, but in the meanwhile, we will also have to take a different steps towards our environment. It's just not the 5G technology that rule the environment. We have so many other things that is currently contributing to the environmental factors. So at this point, I wouldn't jump into that conclusion to say that how 5G can destroy our environment, but we will definitely have to take a cautious step and ensure that this technology provides us a better way of life going forward, as is the case with any advanced technology, right? A knife can be used to either kill a person or to operate on a person. So it depends on the perception as to how we use it. So yeah, I think that's all about 5G that I had in mind to talk in this session. I hope I was able to, at least break the hyphen terms in smaller chunks so that it's understandable to everyone. Any questions do you have?
Yeah, I have a question. So, will the 5G like backbone be physically and virtually separate from the 4G one?
Sorry, Aryan, I didn't get your question.
Like, will the technology or the apparatus behind 5G be different from
Yes, yes,
4G?
yes. So, including your, I mean, the current towers cannot be used as is right away. I mean, it needs some additional infrastructure that needs to be installed to make sure that it is reusable. I'm not saying that it
Okay.
will be entirely junk, but both the infrastructure to enable the transmission as well as the devices that we have. Our mobile phones, unless you have bought a new phone which says it's 5G compliant, won't support it. So we're talking about replacing both the device and as well as the transmission part.
Okay. We have a question in the chat box. Difference between 5G bands like we have N78, N77, etc. What is the difference between these bands?
Hi, Divakar. Yeah, that's a good question. But at this point, I think let's stick to the intro part, and I haven't, digged into the different type of bands because there's a lot of other technologies that are involved. So yeah, probably in the coming week we can, get in depth and see what are the different band types and etc.
Okay. We have another question in the chat box.
Yeah.
Will 5G change the current while an architecture used for 4G?
Yes and no, because it cannot be fully reused as is. There still has to be some additional things that have to be applied to ensure that they can be reused.
Okay. I think Tanvi, that answers your question, Tanveen. Next, we have how will 5G travel longer distance when it can be blocked easily?
Yeah, so that's where these small cells come into picture. So they'll just not one set of beams that will be sent. There will be a lot of a transmission that happen between the transmitter and, I mean, the receiver and the transmitter to form a best path so that there is a signal transmission without any interruption. The pictures that I showed, it's like a very noise one so that people can understand how it goes. But there is a lot of things that happen in the background so that those signals are distortion free.
Okay. Next up, we have will 5G
Will
be
5G
better
be better
than?
than optical fiber? Yes.
Yeah.
When it comes to the full potential, so we are talking about uh, uh, um, at least 10 Gbps to 20 Gbps.
Okay. Uh, any more questions, guys? I think that's all.
No question, Aryan.
Okay.
Great. No worries. Thanks, guys. Thank you for joining.
We have one more question.
Okay, what
What
kind
kind?
of internet is provided by satellites like Starlink? Well, if in the advanced level of 5G, even there are talks about using satellites as well for the transmission, because I think there are plans of using these small satellites which can be used as these small cell which can transmit information. I mean, it need not be on the ground. It can also be on the in the space and support the transition. But at this time, I think it's very there's no definite answer as such. It's still evolving, so we will have to wait and watch how best these technologies will be turned into. In a I think if we can term it, it is very in a very basic baby steps that have other companies have taken. I don't think 5G is open to everyone in its full capacity as yet throughout the world.
Uh, I think that, yeah,
Will
that
we
answer.
have a carrier aggregation over 5G in future? Yeah, could be, could be.
Any more question, guys? No, I think. Yeah, Tanvin, you can go ahead.
No, Aaron, I don't have any questions.
I was talking about the closing.
Sure, sure. Thanks, guys. Again, thanks for joining in. Have a good evening.
Thank,
Yeah.
thank you so much, Vikas,
Can
for joining in and making this session more informative for us. And like
No
we
worries.
really gathered a lot of information, I guess.
Okay, Sai Harshad is asking, why don't we instead use short range 5G? Can you answer that, Vikas?
When you say short range, what do you mean, Sai Harshit?
Yeah, you can go ahead, Sai. You can unmute and speak. Like limited to a small area or cafe or building.
Well, for that, maybe it will work just for the cafe or the building, right? But we are talking about connecting everyone and everywhere. So at some point, it will still have to be extended to a wider audience, right?
Yeah.
And even the current implementation of the 5Gs, if you see, these are all limited to a certain laboratories or anything. It's not publicly available for everyone. So the current 5G implementations that the other countries are projecting, it's at a very low scale.
Yeah. Thank you for that. I think we are done for the.
Go ahead about feedback form.
Yeah, yeah,
Aryan, about feedback form and
yeah.
screenshot. Go for it.
Guys, I'm sharing the feedback form, so please go ahead and, yeah, please fill the feedback. Can we have the cameras on for a screenshot?
Sure.
Vikas, I thank you on behalf of BMSIT for giving such an useful information. It was
Yes,
really
thank you,
an
ma'am.
interesting
It
topic.
was a pleasure.
Thank you, thank you.
Yeah.
And the organizers also, thanks a lot. You have done it very fine, very nicely. You have organized it.
Thank you, ma'am. Guys, please turn on your cameras for a photo. Surbhi, Srinidhi, can we have your cameras be on? Yeah, on the count of 3, 2, 1. Yeah, thank you.
Thank you.
Yeah, thank you, because that was a really informative session today. I think we'll have more editions on this in coming
Sure,
months.
sure.
Yeah. Yeah, guys, thank you. Enjoy
Thank
rest
you.
of your
Bye-bye.
evening. Yeah, bye.